Welcome back to another video from MechCloud Academy. Today we're kicking off a two-part series designed to help you master Nginx for modern web applications. My name is Steve, and in this first video we will go through the most essential Nginx directives one by one, explaining what each one does with a clear, focused example. In part 2, we will take these individual tools and assemble them to solve complex, real-world challenges. The location directive is the traffic controller of Nginx. Its primary job is to match the URI of an incoming request and determine which set of instructions to execute. Understanding how it matches is critical, and Nginx follows a clear logic. First, it checks for an exact match, which you specify with an equal sign. In our configuration, a request for exactly/login will always be handled by this first block, which we're proxying to a dedicated auth_ service. This is the most efficient way to route a specific, known URL. If there's no exact match, and Nginx then looks for the most specific prefix match. Imagine a request comes in for /API/users. This request technically matches two of our blocks, /APIs and the generic /. Nginx will always choose the longer, more specific prefix, so the /API/block is used, forwarding the request to our API_backend_ service. This allows you to route entire sections of your site to a specific backend. Finally, if a request doesn't match any of the more specific blocks, it will be caught by the generic location /. This block acts as a final catch-all, making it perfect for directing all other traffic to its default destination, like our main frontend_web app_ service. Once Nginx has matched a location, the next step is usually to send the request somewhere. That's the job of proxy_pass. This directive turns Nginx into a reverse proxy, taking the client's request and forwarding it to another server, which we often call an upstream or backend server. In this configuration, any request to our Nginx server is passed along to an application running on the same machine, 127.0.0.1 at port 8080. This pattern is fundamental for modern architecture. It allows you to expose a clean, public-facing server on standard ports 80 and 443, while your actual application code runs securely on an internal, high-numbered port. It creates a powerful separation of concerns, letting Nginx handle tasks like SSL termination and logging, while your application focuses solely on business logic. A single backend server can only handle so much traffic. To scale your application, you need to run multiple instances. The upstream directive is Nginx's elegant solution for managing this. It allows you to define a logical group or pool of backend servers and give it a name. Here, web_backend_pool. You can then point a proxy_pass directive to this group name instead of a hard-coded IP address. This decouples your routing logic from your infrastructure, making it easy to add or remove servers without touching your location blocks. By default, Nginx will distribute incoming requests across all servers in the pool using a round-robin strategy. This simple load balancing dramatically improves your application's capacity and fault tolerance. If one server goes down, Nginx will automatically stop sending traffic to it and distribute requests between the remaining healthy servers. Sometimes, the URL the user requests isn't the same as the URL your backend API expects. The rewrite directive is our tool for transforming URIs on the fly. It uses regular expressions to match and change the request URI before it's processed further. In this example, we want to support a user-friendly URL like /user/123/profile. The location block uses a regular expression to match this pattern. The parentheses capture the user's IDD+ into a built-in variable, $1. The rewrite directive then transforms the URI into the format our backend expects, /API/v1/users/123. The last flag is important. It tells Nginx to stop processing this location block and start a new search for a location that matches the new URI. The request will now be caught by our /API/v1/users/location and proxied correctly. For securing endpoints, auth_request is the standard pattern. When a request hits our /secure-data/location, Nginx first sends an internal subrequest to /internal_auth_check. This subrequest is proxied to an authentication service. If the service returns a 2xx success code, the original request is allowed to proceed. If it returns a 401 or 403 error, the request is denied. Notice the internal directive. It acts as a firewall, ensuring that your verification endpoint can only be called by Nginx itself, never directly by a malicious user. It's also good practice to optimize this subrequest using directives like proxy_pass_request set_body off, since the auth service often only needs to inspect headers or cookies. This pattern centralizes your authentication logic, so your backend data services don't have to worry about it. Let's focus on proxy_set_header. This directive's job is to modify the request that Nginx sends to your backend server. Think of it as passing important notes internally. Because your application is now sitting behind a proxy, it loses context about the original client request. These headers restore that context. Host tells your application which domain the user originally requested. xRealIP passes along the actual user's IP address. xForwarded4 maintains a full list of proxies the request has passed through. And xForwardedProto tells the backend if the original connection was HTTP or HTTPS. These headers are essential for your application to generate correct URLs, log accurately, and apply IP-based rules. In contrast to proxy_set_header, the add_header directive modifies the final response that Nginx sends back to the user's browser. This is for external communication and is a critical part of your security posture. Here, we're not sending data to our backend, we're giving instructions to the client's web browser. Strict transport security tells the browser to only communicate with our site over a secure HTTPS connection in the future. Xframe options helps prevent clickjacking attacks by controlling whether your site can be embedded in an iframe. And Xcontent type options prevents the browser from trying to guess the content type of a file, which can mitigate certain types of attacks. Using add_header in Nginx means you can enforce these security policies globally without touching a single line of application code. While Nginx is a fantastic proxy, it's also incredibly fast at serving static files directly from the disk. The root directive specifies the base directory on your server where the files are located. When a request for /images/logo.png comes in, Nginx will look for it at /var/www/my-react-app/build/images/logo.png. But what about modern single-page applications, like those built with React or Vue? For these, the try_files directive is essential. It instructs Nginx to try finding a file in a specific order. Here, it will first look for a file that exactly matches the request URI, like /about. If it doesn't find one, it will look for a directory named /about/. If both of those fail, it will fall back to serving the /index.html file. This fallback is the magic that makes client-side routing work. It ensures that no matter what URL the user enters, your index.html is served, allowing your JavaScript application to take over and handle the routing. By default, when something goes wrong, Nginx shows its own plain, unstyled error pages. The error_page directive gives you full control over this experience. Its most common use is to serve a custom, user-friendly HTML page for common errors, like a 404 not found. But it's also a powerful control flow mechanism. In this configuration, we've specified that if Nginx receives a 502, 503, or 504 error from the backend, meaning the backend is down or overloaded, it should perform an internal redirect to the named location at fallback. Inside this block, we can then serve a static maintenance page or even attempt to proxy the request to a backup service. This ability to intercept an error status and redirect the request flow internally is a key pattern. As you'll see, it's not just for user-facing pages. It's a technique we will use heavily when we build our complex authentication gateway in Part 2. And that concludes our foundational tour of the Nginx toolbox. We have now defined and explored 10 of the most important directives for any modern developer. Each of these directives is a powerful building block. With this solid understanding of each individual tool, you are now prepared for the next step. In Part 2, we will assemble these components to solve complex real-world problems. We will build a complete API gateway that needs to handle public and private endpoints, manage cores, and pass user identity securely. You'll see how to assemble these building blocks to solve problems, and also where the complexity can start to become a significant challenge. Thank you for joining us, and we look forward to seeing you in Part 2.